So now I want to show you the guts of this basic game, this little airplane and rockets game, show you how it's put together. And then what we're going to do is I want you to download that game and I want you to try and make it run. And basically to make it run, you need to install Pygame, the module from the modules library. Then you will need to download some images because the images are not included in the code. So you need to download some very small images. You don't want huge images. Remember, these are, let me just show you again. This one, you can see right here, it says it's 62 by 25. So 62 pixels across by 25 tall. That's a tiny, tiny image. If I'm showing it at exact size, right? That's the kind of the size we're looking at. So I'm just zooming way in here so you can see it, but it's 62 pixels across. And then you can see here, oops, that's not that one. Where's the missile? There it is. Okay, the missile is 20 by 10 pixels. So it's very, very small. If you start pulling images off the web and getting big images in there, it's going to be problematic for you. If you want to find cool images, type this, images, game, sprites in Google. And you can go to Google Images, and there are millions and millions of these out there. Now, many of these are going to be too big, so you're going to have to take them into like an image editor and shrink them down or figure out a way to make them a little bit smaller. But a lot of these are ripped from old video games, or people just create them and share them, but you can use them for this project all you want. In fact, if you have a favorite video game, you could probably search for it by name and find it here if it's old enough. So let's take a look at this game here. Okay, so I'm going to run through the code and I'm going to show you how this game is put together using Pygame. By the way, this is the code that I'm providing you as starter code for this project. So you can take this and modify it to create your own game. And that's what I'm actually going to do for you on Wednesday is I'll take this code and turn it into a completely different video game right before your eyes. It'll be magical. So we're going to import Pygame. We're going to import random. That will give us the entire Pygame library and the entire random library. Now you'll notice we have a little bit of redundancy here, but there's a reason for it. We are going to, from pygame.locals, we're going to import these, and if you've been paying attention, you'll know that they are all caps, which means that they are constants. So we are actually importing all of these constant values from pygame.locals. And the reason we're doing it this way is so that we can refer to these directly by name. Now, this is a hardware acceleration that helps us make our graphics run more smoothly. I'll show you where we use that, but that's about all you need to know about it. K up, K down, K left, K right, K escape. You can probably imagine that those are mapped to keys on your keyboard. So they actually refer to hardware locations of keys on your keyboard. Key down is an event that it looks for, and quit, obviously, is when the game ends or when you close the window. So we're going to refer to these throughout our code, but it makes them easier to deal with. We are also going to define two constants of our own. Remember, a constant is just a variable that doesn't change. So it's a word or phrase that represents a value, but it's not intended to change. That's why we have it in all caps, so we know that it's a constant. But we're setting a screen width value of 800, a screen height of 600. Now, I could just write 600 and 800 anywhere I needed screen width and screen height. But the nice thing about this is that if I use constants for those things and all of a sudden I want to make my game window larger, all I have to do is change them in one place. And then everywhere else they're used throughout the code, it updates for me. So that's a nice benefit. So those are the imports and the constants. Next, we get into building classes. Okay. This is not anything we haven't already covered in class. What you'll notice, you'll see here, class player is the player sprite that we're going to create, and we are basing it on, or we're inheriting from pygame.sprite.sprite, which is the generic sprite class that Pygame provides us. So we're inheriting lots and lots of stuff from that sprite class. You can see here we call the initialization method, and we're calling the super initialization method. Next step, pygame.image.load, and we're loading the image for the jet. Okay, so this is where I'm loading the image. If you don't have this pointing to your image file, Pygame will not run. Okay, so this is the number one biggest hangup that people get in trying to get this code to work, is that this address has to point to your image file. The easiest way to do that is to save your image in the same directory as your script after you download it, and name it something simple, and then make sure that matches the name of your file. .convert is just a method that says convert this so that Pygame can use it. Okay, so self.surf. So the surface property of the player class is set to that image. The second line right below it at 27 here, where it says self.surf.setColorKey, is a place where I am taking that white background of that image and turning it to transparent. So setColorKey takes one color and makes it transparent in the sprite. So I'm setting all of the white pixels. That's a tuple that represents white. I'm setting those to transparent, and I'm using that hardware acceleration to make that happen on a rapid basis. Okay, so there I am defining what my sprite will look like. It uses that jet image, and it uses transparency on all the white pixels. Next, self.rect, rectangle. So I've got the surface, here's the rectangle, and you can see self.surface.getRectangle. So I'm using the actual surface, the surface of that, and a getRectangle method of the surface to set the rectangle to the size of the image. That's all it means, is just the rectangle is the size of that image. So when I create the player, it does all those things. Next, I'm defining an update. An update method. Every sprite should have a method called update, because when the game loop runs, it's going to update every sprite. So we've got an update, and in this case, the update gets all of the keys that are pressed when the game loop is running. So when you get to that game loop, it wants to know what keys are pressed. And it says, if the up key is pressed, then we're going to move the rectangle 0, -5. What that means is we're moving it not left and right at all, but we're moving it up 5, because minus is up, plus is down. And then on the X and Y coordinate, or the X coordinate, -5 is left, +5 is right. So if I want to make my airplane move faster, all I have to do is increase the number of spaces that it moves each time I press a key. If I've set it to 10, it'll move twice as fast. Okay, so this is where if the keys are pressed, I'm moving the airplane. Then it shows a section here that says, let's make sure that you can't fly the airplane off the screen. Now, if I take this and I comment it out and I run that code, what will happen is I can fly that plane right off the screen, and I can fly it back on the screen. Because when I fly off the screen, it actually is still there. Pygame keeps track of objects when they're off the screen. So that plane is just sitting there invisibly out of the window until I decide to fly it back on, in which case I can. And all four sides of the screen, now that I've removed that code, it allows me to cheat, kind of. But this code basically says, and you can look at this, if the left side of the rectangle is less than 0, so if I have a screen that looks like this and I have a rectangle, it's saying if the left-hand side of this is less than 0, because this is 0 and 0, right? If it's less than that, then stop it right there. Don't let it go further than that. So that is, it's doing that for the left-hand side. If the right-hand side is greater than the width of the screen, there's that constant again. If the top is less than 0, if the bottom is greater than the screen height. So it's just keeping it in that rectangle. And believe it or not, that is it. All of the player's movements and controls and how it looks are all done. The next class is the enemy. In this case, the enemies are spawning off screen over here and flying onto the screen. So it looks like the missiles are being like shot from somewhere far, far away, rather than just appearing in the middle of the screen, which looks kind of dumb. So we have an enemy. It's based on the sprite. It's not player controllable. So we don't have to worry too much about that. But again, Pygame images, we're defining the white pixels as transparent, and we're using the rectangle is based on the surface size, and then we are putting the center of this, okay, so we're placing it on the screen, and we're using random to say we're going to put that image on the x-axis somewhere between the screen width plus 20 and the screen width plus 100. So it's random in that area. And then the screen height, we're saying we're going to take the screen height. I can't reach all the way up there, but we're going to say we're defining a box where the missiles are going to be placed somewhere in that box when they appear. But they're always going to be off screen. So the little missiles will appear somewhere in that box, and then they're always going to fly this direction onto the screen. So we are also giving the missile a self.speed, so a speed property that is a random integer between 5 and 20. So now, here's our update method. Every sprite should have an update method so that it knows what to do. So we're doing, every time it updates, we are moving negative self-speed, which means it's going to the left, somewhere between 5 and 20 places, and it's not moving up or down at all. And then it says, if the right-hand side of the sprite, gets past the screen on that side, then we kill it. Why is that? If we don't, our program's going to have a big memory leak, because I'm spawning a whole bunch of these every second, and they're just going to fly off into infinity. They'll keep going. If we don't kill them when they leave the screen, I'm just going to have a million missiles flying off in forever, because Pygame will actually keep track of each sprite until it's killed. So we don't, even though they're out of sight, out of mind, Pygame will keep track of them. So we have to make sure we're cleaning up our garbage by killing those when they leave the screen.